In this video, we are going to talk about how to take the derivative of a composite function. And we're going to think about composite functions in terms of inside functions and outside functions. So let's look at a few examples. Let's look at this first one. We have y equals 2x plus 5 raised to the third power. So that inside function here is going to be 2x plus 5. The derivative of that inside function would be 2. And our whole goal is to rewrite this in terms of something that we know how to take the derivative of, because we don't know how to take the derivative of a binomial to a power. But by doing a u substitution in the chain rule, it helps us tweak an existing rule. So this is my u, so I'm going to rewrite this as u to the third. And this is easy to take the derivative of. So it's going to be 3u squared, and we need to show we took that derivative with respect to u. So we're going to tack on a du anytime we take that derivative. And this is really a form of implicit differentiation that's going on. And then we're just going to substitute back in. We have 3u squared times du. So my u was 2x plus 5. And then my du is 2. And then we're going to clean that up. 3 times 2 is a 6 times 2x plus 5 quantity squared. So this is really a 5-step process that's going on. We're identifying u. We're going to take the derivative of that u. We're rewriting in terms of u, and then we're taking that derivative, and then we're back substituting. And that's going to work for any of these. Let's look at this one down here. Our inside function is 5 minus 2x. So you always start by identifying u. You get to pick u. Du comes from whatever you picked. If I pick this for u, my derivative of that would be a minus 2. So now I'm rewriting this. So if this is u, I'm calling this u to the fourth. And then I'm going to take the derivative of u to the fourth. That's going to be a 4u cubed. And you always have to show you took that derivative with respect to u. And then now we're just going to substitute back in. So this is 4u cubed du. U was 5 minus 2x. So that's what's being cubed. And the derivative of that inside function was negative 2. And then we're going to clean it up. This is really negative 8 times 5 minus 2x to the third. Okay, we do not need to multiply those out. It is fine to leave it as is. Okay, let's look at another one. Let's say we want to look at this one. Inside function would be 3x squared plus 5. The derivative of that would be 6 times x. So if I rewrite this, this is going to be u to the fifth. The derivative is 5u to the fourth times du. And then we're going to substitute back in 5u to the fourth du. So what goes here is my u. This is 3x squared plus 5. And then du is 6 times x. And then we're just going to simplify. 5 times 6 is 30. So that's a 30x times 3x squared plus 5 raised to the fourth. And this is where you may want to pause the video and try a few of these. These are the ones that I'm going to work out in the video. And this is a typo. It should say y equals 1 over x to the fourth plus 1 squared. So pause the video, try those, come back, and then check your answers. So looking at that next one, u, that inside function is 5x squared minus 3. The derivative of that is 10x. My rewrite would be u to the 6th. The derivative of the rewrite is 6u to the 5th times du. And then we're going to substitute back in. U is 5x squared minus 3. Du is 10x. And we're going to clean that up. 6 times 10x is 60x times 5x squared minus 3 to the 5th. On this one, the argument of sine, which is 4x, is my inside function. The derivative is 4. So now I'm looking at taking the derivative of sine of u. Derivative of sine is cosine times du. And then we're going to substitute back in. My u was 4x, my du is 4, so this is 4 cosine of 4x. And that next one, we have tangent of 3 tangent of x squared. U is x squared. Du is 2x. So my rewrite is 3 tan of u. And the derivative of the tangent is secant squared. And then we're going to substitute back in. My u was x squared, du was 2x, and then we always clean it up. So this is 6 times x times secant squared of x squared. If we go down to this one, my u, that inside function is 2x minus 5. The derivative of that is 2. So I could rewrite this as square root of u, which is the same thing as u to the 1/2, and I need it in this form to take the derivative. I'm going to bring the exponent down, subtract 1 from the exponent, times du. So my 1/2, I'm going to have 1/2 times u, which is 2x minus 5, to the negative 1/2 times du, which is 2. So you can see that 1/2 and 2 is going to cancel, leaving us with 1 over square root 2x minus 5. If we look at that next one, inside function is x to the 4th plus 1. The derivative of that is 4x cubed. So my rewrite would be 1 over u squared, which we would rewrite as u to the negative 2. And then now we can take the derivative. Bring the exponent down, subtract 1 from the exponent. So we're going to have negative 2 times u to the negative 3 times du. U is x to the 4th plus 1. Du is 4x cubed. And we're going to clean this up. That's going to be a negative 8x cubed over x to the 4th plus 1 quantity cubes. This one, we have x to the 5th plus 2 as my u. Du would be 10x to the 4th. So this is negative 7 over u cubed, which is negative 7 u to the negative 3. The derivative would be 21 u to the negative 4 times du. And then we're going to substitute in. And then I'm going to clean that up. So this is 21 times 10 is 210 x to the 4th all over x to the 5th plus 2 to the negative 4. So you can see that 5-step process. It works for any chain rule problem. The first step is to identify u. Second step is to find du. This is going to be your inside function. And then you're going to do a rewrite. We're going to rewrite in terms of u. Step 4 is to take the derivative with respect to u. And then after you take that derivative, you're going to sub back in. Your final derivative should be in terms of x's or whatever that initial variable was. So let's do some that's a little bit more interesting. Suppose we want to take the derivative of f of x equals x squared times square root of 1 minus x squared. So this is going to be a product rule. So the product rule says it's going to be the first function times the derivative of the second. I'm doing my setup step. Plus the second times the derivative of the first. Question is, how are we going to take the derivative of this guy? So I'm going to pull that out to the side, and we're going to do a chain rule. So I need to take the derivative of 1 minus x squared, the square root of 1 minus x squared. So let's go through our 5-step process. We're going to pick q. That's going to be that inside function. The derivative of the inside is minus 2x. When we rewrite this, this is the square root of u, or u to the 1/2. And then when we take the derivative, we're going to use our power rule. And then when we substitute back in, u is 1 minus x squared to the negative 1/2. So I have 1/2, 1 minus x squared to the negative 1/2 times du, which is minus 2x. And then we're going to clean that up. So you can see how those are going to cancel, those 2's. So I'm going to be left with a negative x times 1 minus x squared to the negative 1/2. So that's what's going to go in here. So first times derivative of the second. Plus second times derivative of the first. And I'm going to rewrite that square root as a 1/2 power. And then let's clean this up. X squared times a negative x would be a negative x cubed. And then we're going to factor some things out. So these have an x in common, but they also have this group 1 minus x squared in common. So when we factor out, we're going to factor out that to the smallest exponent. So our smallest exponent is a negative 1/2. So we're going to factor out x and a 1 minus x squared to the negative 1/2. And then we're going to talk about what's left over. So if I factor the x out, I'm going to be left with a negative x squared. And if I factor that group out, I'm going to be left with a 1. For this term, if I factor out that x, I'm going to be left with a 2. And then with this, if I factor out the 1 minus x squared to the negative 1/2, I'm going to be left with a 1 minus x squared. Okay, the reason is if we were to multiply that back, we should get this step back. And when I multiply this and I add those exponents, I will get that positive 1/2 exponent back. So I'm going to have x times 1 minus x squared to the negative 1/2. And I'm going to clean this up. This is negative x squared plus 2 minus 2x squared. So I have x times 1 minus x squared to the negative 1/2 times 2 minus 3x squared. We could leave it that way, or we could rewrite this by moving that 1 minus x squared to the negative 1/2 to the bottom to make that a positive exponent. And I'm just going to rewrite that as a square root. Okay, let's do one more. But you can see how we're using that 5-step process there. Let's say we have f of x is equal to x over the cube root of x squared plus 4. So I'm going to start by thinking about that denominator as x squared plus 4 to the 1/3. This is going to be a quotient rule. Quotient rule says is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay, so there's my setup. Bottom derivative of the top minus top derivative of the bottom over the bottom squared. Question is, how do we take the derivative of this? That's going to be our chain rule, so we're going to do this off to the side. So x squared plus 4 to the 1/3, and we want to take the derivative. U is x squared plus 4. Du is 2x. So when we rewrite that, this is really u to the 1/3. And when I take the derivative, I'm going to bring the exponent down. I'm going to subtract 1 from the exponent times du. And then we're going to substitute back in. So it's going to be 1/3 times x squared plus 4 to the negative 2/3 times du, which is 2x. And then we're going to clean that up. So 2x over 3 times x squared plus 4 to the negative 2/3. So now that we know this derivative, let's finish this problem. X squared plus 4 to the 1/2. The derivative of x is 1 minus x times this derivative, which we just found. 2x over 3, x squared plus 4 to the negative 2/3. All over that denominator squared. When we have a power to a power, we multiply the powers together. 1/3 times 2 is 2/3. So I'm going to do a cleanup step before I do a factoring step. Need to go back and fix an error. This should be a 1/3 here, and then here, and then here. So let's look at what these terms in the top have in common. Okay, first thing I want to do is I want to eliminate this fraction within a fraction, the complex fraction. So I'm going to multiply the top and bottom both by 3. And when I do that, I'm going to have 3 times x squared plus 4 to the 1/3 minus that 3 and this 3 is going to cancel, leaving us with a minus 2x squared times x squared plus 4 to the negative 2/3, and that's going to be over 3 times that denominator. So that eliminates my complex fraction. So now let's factor. This term and this term have that group in common. And remember, we're going to pull out that group to the smallest exponent. So we're going to pull out x squared plus 4 to the negative 2/3. And then we're going to talk about what's left over. So if I pull that out here, I'm going to be left with the 3, and I'm going to be left with the group x squared plus 4, because if I were to multiply these back, I would add the exponents, and I would get that 1/3 there. Here, with that second term, I'm going to be left with the negative 2x squared, and we factor that entire group out. That's going to be over 3 times x squared plus 4 to the 2/3. So now this term, oops, I don't know why that moved. This term can come down here. And then we're going to distribute the stuff in the top. So I'm going to have 3x squared plus 12 minus 2x squared over 3. And this is going to be x squared plus 4 to the 4/3. And then just combining white terms in the top, I have an x squared plus 12 in the top over 3 times x squared plus 4 to the 4/3. So there's my final answer. So let's do another one. Let's say we have y equals 3x minus 1 over x squared plus 3 quantity squared, and we want to take the derivative. So we're going to do a u substitution. Our inside function is that quotient, 3x minus 1 over x squared plus 3. So du is the derivative of that, and that's going to be a quotient rule. Quotient rule is the bottom times derivative of the top. So this is my setup step. Minus top times derivative of the bottom over the bottom squared. So we're going to have x squared plus 3. The derivative of the top is 3 minus top. Derivative of the bottom is 2x over bottom squared. So we're going to multiply everything out. 3x squared plus 9 minus, and this is going to be 6x squared minus 2x over x squared plus 3 squared. So 3x squared minus 6x squared is a minus 3x squared. This is going to be a positive 2x, and then we have a plus 9 there over x squared plus 3 quantity squared. So that's the derivative of our inside function. So we found u, du. Now we're on the rewrite step. So this is really going to be u squared. And the derivative of u squared is 2u du. And then when we substitute back in, it's going to be 2 times our u, which is 3x minus 1 over x squared plus 3, times our du, which is negative 3x squared plus 2x plus 9, all over x squared plus 3 quantity squared. And then we're just going to clean this up. I am not going to multiply everything out. Most of the time you want this in factored form. That denominator we can combine. We're going to have x squared plus 3 to the third. So there's my derivative. Let's do a couple with trig functions. Let's say we have y equals cosine cubed of x. So remember what this means. This is the cosine of x quantity cubed. So my u, my inside function is the cosine of x. Derivative of the cosine is negative sine. So then when we rewrite this, this is going to be u cubed. And the derivative of u cubed is 3u squared times du. And then we're just going to substitute in what we know. 3u squared du. U is cosine x. Du is negative sine x. So this would be negative 3 cosine squared x times sine of x. And eventually you're going to do so many of these that you won't necessarily have to rewrite that out. You'll say, oh, I know cosine's my inside function, so I'm going to bring that exponent down. I'm going to subtract 1 from the exponent, and then I take the derivative of the inside. And the same thing's true when we go back to some of those from the beginning. I'm going to scroll back up here and make this a little smaller. You can see that power rule, and it's called the general power rule, come out here. So go back to this one. We would bring that 3 to the front. We would subtract 1 from the exponent, and then we would take the derivative of the inside. And that's really all the chain rule is, especially for something that's written in terms of a power rule. So here we would bring the 4 down, subtract 1 from the exponent, derivative of the inside. Even here, this would be sine of u. Derivative of sine is cosine, derivative of the outside function. And then we take the derivative of the inside function and we multiply them together. So let's look at one more. Let's say we have f of x equals sine to the fourth of 2x. So we're going to peel it kind of like an onion. That outside function, if we think about this, is going to be that sine raised to the fourth power. So let's bring that exponent down and let's subtract 1 from the exponent. So now I have sine cubed. But then you got to take the derivative of the inside. Well, the derivative of sine is cosine. And then we got to take the derivative of the angle. So this is a repeated chain rule. And then we're going to clean this up. So this is 8 sine cubed of 2x times cosine of 2x.